So
Yeah.
what is the electric universe? In the modern sense, the electric universe is sort of a mini pseudo conspiracy theory that that the galaxies, stars, and pretty much everything in the universe runs on some sort of electromagnetism or some sort of hidden fields, hidden currents, some esoteric question mark. Um, I guess it's nice to step back is that basically from the discovery of electricity, not talking about the discovery of amber static electricity, but when it went to Benjamin Franklin, or not Franklin, the the key, damn, it was Franklin, yeah.
Yeah.
The from the discovery of electricity coming from the clouds and this and Alessandro Volta and the stuff in the 16s and 1700s, electricity became this thing that was sort of magic. It was it was an it felt alive. It could, if you were shocked with it, you would jump. It felt like this actual life force. And at the time, and for a long time, that was considered the thing that made the universe run. You'll see even the sci-fi literature of the time. You'll see Frankenstein, where the dead body is reanimated from life from a bolt of lightning because electricity was the life force. And this trend continued for a long time, and it became more and more solidified over the years. It better mathematics, better coils. I'm condensing a few hundred years, but the essentially we started being able to build machines that were electrical in the around the 1800s, 1900s, building motors, coils, generators, light bulbs, all the cooler stuff, the stuff we see of electricity nowadays. And the formulas and the math started getting developed pretty well, but the problem was there was sort of a counterculture or a counter community that was based more in the realm of physics and we'll say an anti-electricity team. And that team had made quite a bit of headround, and a lot of university professors and stuff. This would be essentially the Einsteiner. It came into this thing of the Einsteiner move versus the heavy side view, or the electrical view versus the billiard ball view of reality, not just Earth, not just everything, but it was sort of the question of uh, there was two different possibilities. It was either that we have matter, we have atoms, matter, subatomic particles, and these subatomic particles mesh together and create these things that we called electricity. Now, at the time, there was the opposite view that electricity is the fundamental view. And with dielectric fields and magnetic fields, the complex interaction creates these things that look like atoms and these things that look like subatomic particles. So, uh, essentially what happened was all of the people that were doing those great things, Tesla being, of course, the most popular, but there are lots of others that contributed huge efforts. But when they died, the universities didn't really carry on much of the tradition besides what they needed to, enough to get the light bulb running, enough to get the outlet working, to keep the grid running. But they sort of delegated it to this little fringe thing, this little byproduct of matter and subatomic particles was this electricity thing. There were no fields, there was no underlying principle. So what happened was, it makes sense how this was the electric universe of the day, which was electricity being the fundamental force. Uh, Post Einstein era, that sort of went away. So all you have is gravity,
Yeah, because Einstein.
magical dark matter, and other things that sort of try to fill in the gaps, but not quite. They try to how do you say it? They try to build a system missing some tools. I don't know how to phrase it, but yeah,
Yeah.
this is the electric universe as it's seen today.
Why are so many mainstream physicists against this? Or at least I assume that a lot of them are against this.
I
Uh,
think one of the reasons
it's
was
not taught
Einstein
most in
deliberately.
Hold on,
it's
one at a
taught in
time.
a specific it's taught in a very specific way that marginalizes the importance and existence of electricity. Is that if you teach it as atoms first, electricity later, versus teaching it as electricity first, atoms later. So when you see it from the wrong fundamental perspective, you're sort of mind blocked. There's this mind virus, and you can't see things in that other perspective. And when you see things from that other perspective, all of a sudden a lot of questions start becoming answered.
I think
Pamad,
that Einstein also, he basically said, well, he did explicitly say that the ether does not exist. And the ether, can be defined as a luminous body of light through which light waves travel.
The historical definition of the ether is the medium which conveys light. So basically, this is the thing that light travels through. If we're talking sound, we're speaking. The air is the medium that our voice travels upon. This is the vibrations and the pressure waves that travel across the air. There was supposed to be the same thing. There's a fabric in space, and light travels across this same fabric with that same principle. We are in an interesting state today, is that we say the ether doesn't exist, but we still use it in all of the formulas.
Right.
It's that we call it space
Isn't that
time.
the
We
most
call it space
unbelievable
time.
thing? They won't accept the fact that ethers exist, and yet it's the fundamental building block of every single equation ever written. It's the most insane thing I have ever studied. It's crazy.
Technically, they call it space time, but they do not want to call space time an ether.
Space time and the ether is not even quite exactly the same. It's just they don't really want to actually delve into the spiritual side that could be literally easily connected to all of it. Instead, they'd rather just relegated it to like whatever they could physically describe, instead of like being literal and including the fact that there's a spiritual side to like the way the universe operates. It just refused to incorporate the spiritual side, and it's so frustrating as a observer. I'm not a person today, but
it makes sense from a perspective, though, because as a scientist, you want to be able to know everything. And if you have a system that is so complex that you can't possibly understand it, the mind boggles. Is that you wouldn't want to bother with that, because then all of a sudden the universe is magic.
Well, what is energy? They don't know what energy is. I mean, I'm sorry not to be arguing this, but what is energy? They don't know what energy is. They can't even like quantify energy properly. Every time they quantify it, they have to re-quantify it because their previous quantification was wrong. Like, I wish scientists would accept the fact that they know nothing. That would make life.
They're not as humble as they should be. Yes.
Masturbatory drug addicts, like they're addicted to materialism to the extent which they will literally go through the most mental gymnastics in order to ensure that like they can't talk about metaphysics.
Well, we have a comment from Thorsten Flink. I think that may be a Swedish name. Like, I'm trying to figure out who are the people that we're getting from Alexander Bard, and that does sound like a Swedish name. Anyway, and please confirm, Thorsten, if you do come from Alexander Bard. Anyway, he says, nah, it's not electric, lol. Dark matter will eventually be explained, perhaps with complex fields and hyper-complex numbers. Octonions are an example of where the field is headed. So, any comment on that?
Dark matter. So I guess it helps to understand where the term dark matter came from and what the concept is. So what happened is we started getting really good telescopes and really good views of the universe. So they took the Newtonian idea of gravity. They said this many meters per second for this much mass. They added up all of the mass of all of the stars of the galaxy, and put all the numbers together, and it turned out that there wasn't enough matter to hold the galaxies together. That there was all of this missing matter that they couldn't explain. So what they ended up doing was they had this little fudge factor. Essentially, the formulas weren't only off, they were off by 95%. They were off by orders of magnitude. So 5% of what we could see, there was 95% of the mass that was missing. So what ended up happening is there was a little fudge factor. And that fudge factor, that's times 20, is what we call dark matter. That's where dark matter came from. There was a bunch of different theories and tests and hypotheses to explain what it is and how you could falsify it and what you could do, but all of them failed. I think we're probably more than $20 billion down the drain over the last 50 years, and at the moment there is still no physical evidence for the existence of dark matter. because it never existed. It was a fudge factor. There's something else missing that you're not seeing. So what's probably going to happen is there are some alternatives to dark matter that do solve the problem without using, you know, these invisible, undetectable unicorn particles. But they don't really like them because most of the theories that do that also have some sci-fi ramifications.
What do you mean by sci-fi?
Yeah, but the collider, bro. Like, we spent all the money on the collider, bro. I fucking love science, bro. Like,
that's a public works project.
One
of the alternatives to dark matter that I like is called quantitized inertia, and there's a physicist, Mike McCullough, that's very active on Twitter. You should look him up. But the principle of this is that it's sort of a mesh between special relativity and quantum mechanics. It's really difficult to understand, and I'm probably not even quite there myself. But some of the ramifications is that you can create artificial thrust, artificial gravity, time dilation becomes possible. And basically, you know, the whole UFO thing becomes not only possible, but physically engineerable. Like, these are the formulas to do. This is what you have to build with this shape and this power. You get this many micronewtons of thrust. And actually, it was one of the things that interested me. If you go back about a year on my Twitter, I was experimenting with some of that with a colleague, because it turned out the test to confirm this quantitized inertia theory was not all that difficult. You just needed a really, really sensitive scale of an LED, lasers, you know, little fancy equipment, but nothing that was out of reach of the experimenter. And one of the things I sort of went on a hiatus for that, just got into other projects. But one of the things I did leave is a project on Thingiverse, where it is essentially a 3D printable microgram balance. So it's a balance, but it's designed that you can tune the sensitivity down to the point where you read below a milligram, which for reference, the accuracy will get, if you took a single sesame seed and you cut the sesame seed into 20ths, that's roughly how accurate you can get.
Wow.
I love the fact that the raccoon is the smartest one of all of us right now on the stream.
I think the goggles is what did it.
We got this cartoon just speaking the absolute truth. It's amazing.
Exactly.
And anybody have questions, let me know. I mean, I've crammed this stuff for a couple decades now, so.
Yeah, I mean, I'm speechless right now, but for anybody else, I mean, we also have a comment from Thorsten while you guys are thinking of a question to ask the great raccoon guest that we have here today. So Thorsten says, the issue that holds back development is that testably hypothesis would demand, for instance, a Hadron Collider 100 times bigger than CERN, or somehow precise.
And you know they'll try to get that money too.
You know what I think scientists should do?
Do they know what the sunken cost fallacy is? This is the thing where you continue to go in the wrong direction because you've already spent all the money. You know, we've already spent $20-30 billion looking for dark matter, so it's got to be there, right?
Yeah, what's another 10 or 20? Come on, between friends.
It's got to be. We've got to be so close. Just, you know, 5 more billion and we would have gotten there.
Well, that's kind of like education. That's the way education works in the States with the teachers union and all that. Like, there's never going to be enough money, and the only reason why the education's so bad is, well, of course, where you don't have enough money. If you give us just this much more money, then everybody's going to be fucking Einstein. But we also have another comment from Thorsten. I suggest reading Joshua Engel, Virginia Tech, for a non-technical introduction, active on Quora. So,
we have one other here too, Acer Veneer. Isn't dark matter what is represented by the cosmological constant, lambda, in order to make the Friedmann equations work? Are physicists certain there is even something to look for? This was one of the fudge factor for dark matter that I was talking about, is the lambda part. Now, what's been really interesting lately, the last few years, is that it turns out there's not a constant amount of dark matter. They found a few galaxies that had more dark matter than they should. I'm using it in, you know, air quotes. And then there was a whole bunch of galaxies that turned out to not have any quote dark matter or magic missing matter to hold things together. Yeah, so not only is it bad that they can't find it, but they can't find it. It disappears. The thing they're not looking for isn't it with the right ratios. So they have these little really funny fudges. I think there's fuzzy dark matter, there's cold dark matter. all these
Yeah,
little things to
the
try to keep it
turpentine
together.
What was that, Disco?
Have you ever heard of the turpentine cleanse?
Have not heard of that.
Right. So this is something all scientists should probably do. It's when you drink a teaspoon of turpentine and let the poison eviscerate all the worms in their gut. So maybe it might improve their intuition, so they won't have to rely on their stupid scientific methodology, which they don't even use.
I think it's good to understand why, or exactly how the process, why dark matter survives. Is that if you look back on history, you look at the geocentric universe model. This was the model of antiquity, that the Earth is the center of the universe. The sun revolves around the Earth. The moon revolves around the Earth. All the planets and stars move around the Earth, and the Earth is in the center. So this was the common view for thousands of years. But it wasn't just the common view because the dumb spiritualists. We actually had mathematicians, we had astronomers, we had an entire system built around the geocentric model that was accurate. They could actually predict the motions of all the planets and the stars and the sun with incredible accuracy, with the Earth as the center of the universe.
Yeah, the Chaldeans could predict.
It wasn't until like post Galileo that they had telescopes that were starting to get accurate enough that they could see, once in a while a planet would move the wrong direction. It would go a little spirograph shape. So what happened with the geocentric model is they started creating these epicycles, where the planet would move in this little circle shape, but then there would be a circle within the circle. And then it turned out there was another circle within another circle. So I guess the point was that when the geocentric model was finally disbanded, when people finally gave up on it, it was still incredibly, incredibly accurate, to the point where we could use that model today to launch probes to other planets with it. I mean, even being completely wrong, you can still have very good falsifiable predictions. It's kind of crazy how the world works like that.